Hello，大家好呀！今天这一期的话，给大家介绍一下黑匣子，因为这几天也是一直在忙于找资料，然后的话，听到这个消息也是非常悲痛的。咱们看一看这个黑匣子究竟的原理。
When TWA Flight 800 exploded in midair just off Long Island on July 17, 1996, it caused the death of all 230 people on board. It was the subject of the longest crash investigation in civil aviation history. Eventually, thanks to essential information recovered from the aircraft's flight data recorder, the cause of the crash was revealed. So how do they retrieve and analyze the data on an aircraft's black box?
Bearing 313, altimeter 2997, Marshall on the 150, 24, Eagles 9.
Jim Cash of the National Transportation Safety Board in Washington, D.C. has a tough job. When there's an airplane accident, it's down to him to make sense of the data recorded by two vital pieces of equipment: the flight data recorder, known as the black box, and the cockpit voice recorder.
If you have no idea what happened on an aircraft accident, it's very difficult to prevent another one from happening that was just like it. So we can identify the problem and fix the problem.
Modern flight data recorders cost upwards of $15,000 each. By law, they must record 88 separate elements of the flight, including time, airspeed, heading, and altitude. Most modern boxes, however, are capable of recording over 1,000 individual data streams. Meanwhile, the cockpit voice recorder uses a continuous loop of magnetic tape that completes a cycle every 30 minutes, so it has the last half hour of sound from the cockpit. Both these boxes are typically painted orange and are equipped with an underwater locator beacon. This beacon is activated when a sensor comes into contact with water and will send out a signal every second for 30 days. But to be of any use to air accident investigators, this intricate technology needs to survive some of the worst accidents known to man. The box is designed to withstand an impact 3,500 times its own weight. The exterior is made from quarter-inch thick stainless steel, while inside, an aluminum housing is surrounded by fireproof insulation an inch thick. Finally, bicarbonate of soda is shaken into the container to absorb heat. But short of crashing a plane, there's only one way to ensure these defenses are tough enough. Meet Gary Kirsten. He's made a life's work of trying to destroy black boxes, and thankfully, he doesn't seem to be doing very well. The first test uses a heavy weight dropped onto the box's most vulnerable axis.
This test is a pretty severe test wherein we take a 500-pound weight with a hardened steel pin on it, of Rockwell 42, very hard steel. We're going to drop it from 10 feet. Here we go. Shut the door. I'm arming the dropping mechanism. We're armed. Okay, everybody, here we go. Fire in the hole. Yep, we have impact. Let's see what we got. Here's the hardened steel pin.
A very bent pin, but barely a mark on the black box. Having survived a crash impact, the next major challenge for a black box is surviving high-temperature fuel fires.
We're going to perform a 1-hour high-temperature fire test. This is the same unit that went through the penetration resistance test. You guys ready back there?
The box is subjected to a minimum of 1 hour at 2,000 degrees Fahrenheit.
Yeah!
The crucial data chips in the black box have survived becoming toast.
This is what the circuit card looks like after a fire test. You see the flex print is all burnt and charred and melted off, but the card itself that has the important data on the memory chips is in perfect condition.
Back at the National Transportation Safety Board, Jim can retrieve the data from the box by plugging it into his computer. For more severely damaged boxes, the memory chips inside can be removed using a heat gun and read from directly. Meanwhile, damaged voice recorders often have to be cut open to retrieve the valuable magnetic tape inside. Thanks to Jim's analysis of this simple piece of tape, investigators were eventually able to discover the cause of the TWA Flight 800 accident. Initially, investigators suspected a bomb had caused the crash. However, after an extensive investigation, another explanation emerged.
The airplane was perfectly normal. The flight recorder looked great. The voice recorder was fine. And then all of a sudden it just ended. So we spent a lot of time figuring out the last quarter of a second of the voice recorder and the last few frames of the flight data recorder, what was going on with that aircraft.
Two brief sections of interference on the voice recorder a fraction of a second before the explosion led investigators to realize the accident had been caused by an electrical short circuit, which had ignited fuel in the center tank.
The voice recorder was very telling. We actually had a lot of information to prove that it was not a terrorist explosion. It was actually a fuel-air explosion.
As a result of this crucial piece of evidence, the Federal Aviation Authority recommended changes to the design of the center fuel tank and the installation of electrical components. And thanks to the existence of the flight data recorders, flying is now safer than ever before.
其实这个黑匣子的话，和我们日常数据恢复中所遇到的原理基本上是一样的，只是人家黑匣子这个设计的更加的精密，和这个防火呀、防震呀这种的。像我们日常的数据恢复当中的话，也是经常会碰见这个数据加密呀等等问题。